This is SpaceTime, Series 22, Episode 55. Coming up on SpaceTime, Disproving conspiracy theories about the Apollo moon landings, Hayabusa II undertakes its second successful touchdown on the asteroid Ryugu, and NASA looking at using atomic-powered rockets to get there in half the time. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Following the global celebrations marking half a century since humans first walked on the surface of another world, comes the not-too-unexpected whine of conspiracy theorists who, despite the overwhelming evidence, scientific, eyewitness and anecdotal, still insist the Apollo 11 moon landing was faked. Now, don't get me wrong, there are real conspiracies out there, often perpetrated by religious zealots or by governments on their own people. But there are also many conspiracy theories which are pure fake, often spawned by hatred, racism, criminal gain, jealousy or greed. And there are also conspiracy theories which stem purely from people's lack of a proper understanding of science, or their inability to properly comprehend what they're seeing or experiencing. Then there are the lunar landing conspiracy theorists. Like flat earthers and doomsday cult true believers, these are people who, if they really believe what they're saying, suffer from deep-seated psychological problems, which have already manifested themselves in other, sometimes subtle ways, often noticed by those around them. Scientific tests have shown that these are people who suffer from feelings of inadequacy or inferiority and make themselves feel better by believing that they've been gifted or acquired some special knowledge beyond what the general population have access to. Forget the eyewitness accounts, the millions of scientific documents, the fact that the radio and TV signals from Apollo 11 picked up by dishes around the world from countries other than the United States, including Australia, could only have come from the moon. The fact that America's, in fact the West's great enemy at the time, the Soviet Union, also found the Apollo 11 moon landing to be true. Or the fact that you can physically look at the moon and actually see the lunar descent stages there on the surface. There are laser retroreflectors placed there by astronauts which are being used all the time, and other equipment is also still in place, exactly where it was left up to 50 years ago. Now, there's another way to look at all this as well, from a sociological point of view. If the Apollo lunar landings were faked, as the conspiracy theorists would have you believe, it means that the more than 400,000 people who worked on the Apollo moon landing program, every single one of them has somehow been able to keep the secret that the whole thing was fake to themselves for over 50 years. That easily makes it the best-kept secret in human history. Now, knowing human nature and people and their love for gossiping, that's a level of dedication and discipline that's never before or since been achieved. It would truly be one giant leap for mankind. And there's other proof too. The rocks collected from the moon 50 years ago by the Apollo astronauts. They simply could not have been faked. Those lunar rocks were analysed by international teams of scientists from all over the world, including some from the Australian National University. And their composition provides specific scientific proof beyond any doubt, dispelling any possible notion that the lunar landings were faked. Professor Trevor Ireland, a space rock expert with the Australian National University, says no conspiracy would have, or for that matter, could have made the moon rocks. He says any attempt to make moon rocks in the laboratory would have been a monumental failure and likely cost more money than it took for NASA to get to the moon and back in the first place. Ireland says the lunar soil is like nothing seen on Earth, the direct result of eons, 4.5 billion years of bombardment on the lunar surface. The lunar rocks have compositions which are unique to the moon. And Ireland says the idea of a secret unmanned sample return mission retrieving moon rocks is also practically impossible. That's because of the sheer amount of material brought back, some 380 kilograms of lunar rock and soil. In fact, when the Soviet Union's hopes of beating the Americans to the moon failed, they resorted to robotic sample return missions. But it took 5 failed missions before Moscow's Luna 16 finally successfully returned 101 grams of lunar soil back to Earth in September 1970, well over a year after Apollo 11. For that matter, it was after Apollo 12 as well. That was followed by another 55 grams aboard Luna 20 in 1974, and Luna 24 returned 170 grams in 1976. So that's a total for sample return missions of 326 grams, far short of the Apollo program's 380 kilograms. That's where the technology of robotic sample return missions was at during the late 1960s and early 70s. So, as you can see, getting this amount of material back to Earth was just as difficult as getting the 21 Apollo astronauts on 7 missions to the Moon and back. Ireland says the fact that 6 of those missions landed on the Moon and brought back samples to Earth is one of the greatest achievements of history. Now, Ireland was not part of the team that analysed those first samples of moon rocks in 1969, but several of his colleagues from the Australian National University were: Ross Taylor, Bill Compston, Ted Ringwood and John Lovering. Ireland has worked with these first moon rock researchers and on the lunar materials, and knows the significance of their work as well as the backstories from this exciting time. Everybody knows about Australia's role in relaying live television images of those first historic steps on the moon. But the work done by these Australian National University scientists more than 50 years ago is one of the great untold stories of the Apollo 11 moon landing. For example, Ross led the NASA team that carried out the first analysis of the lunar rocks that Armstrong collected, revealing that the moon had experienced a global melting event in its history. In fact, it was his analysis which revealed that the age of lunar rocks was extremely old, older than anything ever found on Earth. And research by Taylor and Ringwood revealed that the moon had new sets of minerals not found on Earth. Taylor recalls working with bulky gloves on samples in sealed boxes under tight security with armed guards. He often worked from 7 in the morning until 3 a.m. the following day to deliver results to daily press conferences, thirsty for news to feed the huge level of global interest in the findings. Ireland says even today, scientists are continuing to analyse the Apollo moon rocks, and they're still regularly making surprise discoveries. He says for people to question the Apollo missions simply ignores the facts.
The whole concept is sort of somewhat, I wouldn't say bizarre, but it's sort of very self-centered sort of approach to viewing these missions. And so, those of us of that age who saw these men walking on the moon, I've sat on tables with some of these astronauts, I've chatted with them. You're basically saying to their face, you're lying and you don't know what you're talking about. And I find that a complete affront to the endeavours and the efforts of not just the astronauts, but the thousands and thousands of people who put them on the moon. So, I get a bit affronted by this sort of nature as well.
There are something like 400,000 people who are involved from all over the world, who are involved in putting humans onto the moon during the Apollo moon mission era and leading up to that. And to think that all those people could somehow have kept the secret, kept a mystery, kept a hidden truth going in a giant conspiracy theory such as this it beggars belief. I mean, I can't hold a secret in the office, yet alone 400,000 people doing that.
No, that's exactly right. So the whole concept that, the people were, the ham radio operators who were following the mission, were monitoring the delay in transmissions and everything like that. And then you get a conspiracy theory that just keeps on twisting and changing and evolving to suit the particular bent of the person who's advocating them. Is really annoying in some ways.
I think most of the psychological analyses of these people are that they have feelings of inadequacy, feelings of inferiority, and by subscribing to these sort of conspiracy theories, it makes them feel like they have some special knowledge. It makes them feel better about themselves.
I totally agree with that.
Yeah.
Yep.
So let's focus on the idea of faking the moon rocks themselves. How tough would that be?
Oh, that'd be incredibly tough. So we couldn't even make it. We can't make a rock. Rocks are formed at depth. Typically, the igneous rocks are formed several kilometres down. They cool slowly over millions of years, and they can grow incredibly large crystals. We can't grow crystals of that size in a laboratory. All of our experimental charges, where we try to match the conditions that rocks are forming off from in the Earth and on the Moon, those experimental charges are something like 100 milligrams of material, so way less than a gram. There's 380 kilograms of rock that came back from the Moon. So even if we wanted to actually make the chemistry under the right conditions, we wouldn't make the textures of the moon rocks. We just simply don't know how to do that.
And how do you make the radioactive isotopes to decay at the right rate to give you that impression that it's 4 billion years old, as in the case of the Genesis rocket?
Well, that's another thing. If you don't want to believe in radioisotope dating, what can I say? But from a science point of view, every time we look at these rocks, we see a specific suite of ages. So we're going back to ages which predate the Earth, so 3.8 to 4.3 billion years typically. We can measure rubidium, strontium, uranium, lead, potassium, argon. We may get some differences in those ages, but they're totally consistent with the bombardment history of the moon as well. So we know the moon is a very old surface. That's one of the key features of it. We can see lack of alteration in these moon rocks. They haven't been exposed to water. They have all sorts of attributes that sort of put them apart and set them apart from everything we have on Earth.
You've worked with some of the researchers at the ANU who worked with those first moon rocks recovered from the lunar surface. Tell me about that.
So that was sort of amazing. I used to go to tea with Ross Taylor and Ted Ringwood and Bill Compton, and I met Don Lovering on a number of occasions. So these guys were part of a major effort for Australia to actually generate the data which was then used to establish what the moon actually was. So before we went to the moon, there was all sorts of conjecture as to what the surface was. We had a Nobel laureate who basically proposed that the mare, the dark areas on the surface of the moon, were infill of chondrite meteorites, and so they were dark. And then you had a different scenario for the lighter highlands. So we know that's not right, but that was proved not right because we went to the moon and we got rocks. And so those rocks came back to Australia very soon after, in about September of 1969. Ross Taylor had been working on them in Houston. They had a mass spectrometer almost identical to his, so he knew how to use it and use it well. So Ross was basically housed in Houston doing those analyses. We got samples of the rocks back to Australia. Bill Compton was working on rubidium strontium at the time and doing whole rock rubidium strontium, which is all you need really for these really old rocks. And John Lovering and Ted Ringwood were experts in mineralogy and understanding what the conditions under which these rocks formed. So the big thing about all of that was that this is the first extraterrestrial body we'd visited. And so we have meteorites and things like that, but they're completely different from actually going to effectively a large celestial body, which will have its own particular history. And they basically managed to show that the moon had differentiated very early on in its history. It had been totally molten. And just from that one observation comes this whole concept of the impact theories of the origin of the moon. So the Earth was struck by something. Theia, that's right. Theia struck the Earth, say 4.5 billion years ago, and came at just the right velocity and smashed off a whole heap of the Earth's mantle, and this went into orbit and coalesced into forming the moon. And we can see that on just about every object we see in the solar system. If you go and look in detail, there will be a crater on it which is about half the size of that object. And you can imagine that, well, if that object had been a little bit bigger, it would have just smashed the target into smithereens and it would have been scattered and so forth. And we can see that also in the likes of Vesta. It's almost an erosional remnant now. We pick up the meteorites from Vesta. We know what's going on there. Same thing with Mars. We pick up little bits of Mars in the meteorite collections as well. And we pick up lunar meteorites. We know they're lunar meteorites because we went to the moon and we brought those back and they just match identically with what we see.
I would never advocate violence or support it, but I must admit I had a certain comfortable feeling when Buzz Aldrin thumped that moon landing conspiracy guy in the face.
Yes, that's a lovely piece, and that's how society works, isn't it? It's like he bops him in the face, and the guy sues him, and the jury finds Buzz not guilty because it was self-defense. It's just a perfect result.
That's astronomer Professor Trevor Ireland from the Australian National University, and this is SpaceTime. I'm Stuart Gary. Japan's Hayabusa II has carried out a successful second touchdown on the asteroid Ryugu, collecting more samples for eventual return to Earth. Japan Aerospace Exploration Agency mission managers say the data sent back from Hayabusa II confirms the touchdown sequence, including the discharge of the projectile for sampling, was completed successfully. JAXA says Hayabusa II is functioning nominally and the second touchdown ended in success. Hayabusa II arrived at Ryugu, a small asteroid about 300 million kilometres from Earth, back in June 2018. Ryugu is a potentially hazardous NEO or near-Earth object belonging to the Apollo group of Earth-crossing asteroids. The 950-metre-wide diamond-shaped space rock is a rubble pile asteroid, a collection of rocks, boulders and dust loosely held together by gravity. Its low density, which is only slightly higher than that of liquid water, suggests that it's mostly empty space and has accumulated from debris produced by the collisions of other bodies. Ryugu is a rare type of asteroid known as a spectral type CG, which includes the properties of both common carbonaceous or high-carbon C-type asteroids and relatively rare G-type asteroids, which contain strong ultraviolet absorption features, suggesting phyllosilicate minerals such as clays or mica. Earlier on in the mission, Hayabusa II deployed 4 small lander rovers on the asteroid's surface to study its structure, mineralogy composition, thermal behavior, and magnetic properties, and of course to send back pictures to mission managers on Earth. Hayabusa II undertook its first sample collection on Ryugu's surface back on February the 22nd. The sample collection technique involves firing a small titanium bullet at close range into the asteroid's surface, and then swooping down to collect some of the ejecta and dust kicked up by the projectile to a special horn-shaped scoop. Then in April, the 609-kilogram spacecraft began preparing for its second sample capture mission by dropping a 2-kilogram copper impactor from an altitude of about half a kilometre above the asteroid's desolate boulder-strewn surface. The impact blasted a 10-metre wide, 2-metre deep crater, allowing mission managers to access material from deeper down below the crust, a region which hasn't been exposed to sunlight for billions of years. JAXA had targeted Hayabusa II's second touchdown for an area about 20 metres north of the crater, where darker material from inside the crater appears to have landed. The spacecraft then fired another titanium bullet, again creating a spray of dusty grainy debris, which the probe again scooped up with its horn. Scientists want to learn why Ryugu is so dark. In fact, it's among the least reflective bodies in the solar system. It's darker than any known meteorite. Even more mysterious, the material exposed at the bottom of the freshly impacted crater is even darker still. Ryugu's surface is absolutely covered in an unusually large number of boulders, more over a given area than any other asteroid ever explored. Hayabusa II will leave Ryugu in December, flying past the Earth a year later, where it will eject a small sample return capsule, which will hopefully parachute down to the Earth's surface, landing in the Woomera rocket range in outback South Australia. By the way, that name Ryugu, well, it means dragon palace in Japanese, and refers to a magical underwater palace in Japanese folklore, where a fisherman travelled on the back of a turtle, returning home with a mysterious box, much like Hayabusa II's sample return capsule. I'm Stuart Gary. You're listening to SpaceTime. The United States Congress has approved $125 million in seed funding for the development of a nuclear thermal propulsion rocket system. The funding calls on NASA to develop a multi-year plan for a nuclear thermal propulsion demonstration, including the timeline and a description of the sort of missions likely to benefit from such a system. Using chemical rockets in the current system known as home and transfer, a journey to Mars would require launching into low Earth orbit and then igniting your main engines at just the right time to place your spacecraft into an elliptical orbit around the Sun that eventually intersects with Mars as it orbits around the Sun. It's the most efficient way we currently have of getting to Mars with the greatest payload for the least amount of fuel. But it takes time. About 6, 7, or possibly even 8 months, depending on exactly where Earth and Mars are in relation to each other as they both orbit the Sun at different speeds. A nuclear thermal propulsion system would take just 100 days. Missions further afield to Saturn would take just 2 years, instead of the 6.5-year journey Cassini undertook. And if you're heading for Pluto, that could be done in just 4 years, rather than the 10 taken by New Horizons. So as you can see, in terms of speed, a nuclear propulsion system has lots of advantages over chemical propulsion. The original nuclear-powered rocket concept was known as Project Orion, and it was using a different system known as nuclear pulse propulsion, in which the spacecraft would be directly propelled by the shock waves from a series of small atomic bombs detonated behind the craft. Early versions of this vehicle were proposed to take off from the ground, involving significant nuclear fallout. Later versions were presented for use only in space. But the Partial Nuclear Test Ban Treaty of 1963 ended Project Orion before it could be tested with atomic bombs. But 2 years earlier, in 1961, NASA and the US Atomic Energy Commission were already looking at a different kind of atomic rocket, known as nuclear thermal propulsion. Chemical rockets work by igniting flammable chemicals and forcing the exhaust gases out of a nozzle. It's all about Newton's third law, which states that for every action there's an equal and opposite reaction, which then pushes the rocket in the opposite direction to the exhaust gases. And nuclear thermal propulsion really works the same way, but instead of using a chemical reaction, it uses tiny marble-sized balls of uranium fuel undergoing fission and releasing huge amounts of energy, which are then used to heat up hydrogen gas to some 2,500 degrees Celsius. This gas then quickly expands, pushing out of the rocket's exhaust nozzle at extremely high velocities, 3 times that of a chemical rocket. NASA set up its nuclear engine for rocket vehicle application on NOVA program in the late 1960s to look at nuclear technologies that could take people to Mars, eventually building the Phobos 2A nuclear reactor, which could generate 4,000 megawatts of power for 12 minutes. But the program was shut down in the early 1970s when NASA began to focus on developing the space shuttle. Another type of nuclear thermal propulsion would use fusion rather than fission reactions. This would be more efficient, produce less radioactive waste, and could use lower levels of uranium enrichment. And like NOVA, it's already undergoing testing. In fact, for the past 20 years, scientists at Princeton University's Plasma Physics Laboratory have been working on a fusion-based nuclear thermal propulsion system developed by Samuel Cohen, known as the Direct Fusion Drive Propulsion System. Known as the Princeton Field Reverse Configuration Fusion Reactor, it uses helium-3 and deuterium plasma confined in a magnetic containment chamber. Helium-3 is rare on Earth but common on the Moon, and it's useful because fusion reactions fueled by it won't generate the high levels of radiation or nuclear waste produced by other reactors. That's why the Chinese want to build a base on the Moon to mine it. The reactor's magnetic containment chamber uses a linear array of coaxial magnets with a pair of small but stronger mirror magnets at each end. A fusion region is centered within the magnetic array, while cooler plasma flows around it to extract energy. The fusion region is about 2 meters long and holds very hot plasma spinning like a motor. An antenna surrounding the motor creates a radio frequency heating system tuned to the specific fuel ions used, creating a current in the plasma. The plasma ions get pumped up with increasing energy cycles until they become hot enough to fuse. And once the ions fuse, they create new highly energetic particles known as fusion products. These fusion products follow paths into and out of the plasma layer as they orbit around the magnetic fields. With each pass, the fusion products lose energy until they get captured by the open magnetic field lines and are accelerated out the back of the engine. Now, while this process sounds involved, it actually all happens in just a few milliseconds. The mirror magnet at the end of the engine converts this electron thermal energy into ion kinetic energy, creating thrust. The advantage of this system is that extra heat from the fusion reaction is converted into electricity in order to power all the spacecraft's auxiliary systems. Scientists say their direct fusion drive would generate up to 5 newtons of thrust per megawatt for up to 10,000 seconds. And of course, it would also be producing all the spacecraft's auxiliary power needs.
The direct fusion drive is a new concept in propulsion based on fusion energy, and it provides in a single package both propulsion and electrical power.
So this direct fusion drive is really a game-changing technology, enabling us to reach deep space destinations much faster and with vast amounts of electric power. NASA is interested in a variety of deep space destinations, such as getting to Jupiter in 1 year, Saturn in 2 years, Pluto in 4 to 5 years. A single DFD engine on the smaller side, so a 1 megawatt DFD engine can do any of those missions. We can literally fly straight to Pluto, fly straight to Jupiter, do not stop, do not pass go, do not collect $200, fly directly to your destination. And that's a dramatically different way to operate deep space missions. It will save time, it will save money, and we'll be able to do more science when we get there.
DFD is still under development at the Princeton Plasma Physics Lab.
In DFD, rotating magnetic fields created by antennas on the front and back of the vessel and on top on the bottom create current in the plasma, and that current helps to confine the plasma and to heat the plasma to about 1 billion degrees centigrade. So the purpose of the DFD is to make thrust, but the fusion reactor makes energy. It makes energetic particles. So you have to convert that energy into thrust. We do that by allowing the fusion particles, the fusion products, pass through the scrape-off layer, heating up the plasma there, and that plasma shoots out the nozzle, generating the thrust.
DFD is different from other fusion concepts because it is much, much smaller.
Ours would be about the size of a minivan.
The current machine, PFRC-2, very efficiently heats electrons, and we're upgrading the power supplies so that we can heat ions.
If we can heat the ions in this machine to about 10 million degrees centigrade, we could prove some of the physics theories that have told us we can make a fusion reactor.
A 1 megawatt power plant is ideal for a wide variety of applications. This includes military forward power, remote power, portable power, emergency power, powering mines in the Yukon, and powering spacecraft.
There's a lot of interest in searching for life on Europa, which is one of the moons of Jupiter. We could get there in 1 year with just a single DFD engine.
With a few kilograms of fuel, we'd have enough power for more than 10 years.
We could deflect asteroids that might be coming towards the Earth that would cause major damage. Working on this is very meaningful. The ability to provide power to people on the Earth, the ability to explore the planetary system, to go beyond the planetary system.
We are excited about the future because DFD opens the door to new applications that are not possible today.
And there you heard Samuel Cohen from Princeton Plasma Physics Laboratory, Stephanie Thomas, Vice President of Princeton Satellite Systems, and Michael Pelusic, President of Princeton Satellite Systems. And this is SpaceTime. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have discovered a possible link between drinking lots of sugary beverages and an increased risk of cancer. The findings, reported in the British Medical Journal, are based on results from dietary questionnaires from over 100,000 participants, examining some 3,300 food and drink items over a period of 9 years. They found that an additional 100 milliliter increase in consuming sugary beverages was associated with an 18% increase in overall risk of cancer and a 22% increase in the risk of breast cancer. The authors suggest that limiting sugary drink consumption, together with taxation and marketing restrictions, might contribute to a reduction in cancer cases. A new study says many vitamins, supplements and dietary interventions don't seem to help people live longer or stave off heart disease and could in fact be doing you more harm than good. The findings, reported in the journal Annals of Internal Medicine, looked at 16 supplements and 8 dietary interventions, such as the Mediterranean diet, and found only a few with clear evidence that they really did help avoid death and cardiovascular events in adulthood. And those that did show some benefit also included reduced salt intake, omega-3s, and folic acid. On the other side of the coin, researchers found taking calcium plus vitamin D actually increased one's risk of stroke. An accompanying editorial cautions about the quality of the evidence, but says that for now at least it's reasonable to hold off on recommending supplements or dietary modification for heart disease prevention. Scientists have discovered that Australia's once-in-a-century drought in the early 1900s caused mass ecosystem collapse to more than a third of the country's plants and animals. A report in the Proceedings of the National Academy of Sciences warns that with climate models predicting more frequent and more intense droughts due to anthropogenic climate change, an increase in such events could be devastating for global biodiversity. Australia's Federation Drought, as it's called, was one of the world's worst recorded mega-droughts, with much of the country receiving less than 40% of its average annual rainfall, with 1902, the year after Federation, being the driest year on record. NASA's satellites have discovered the world's biggest seaweed bloom, stretching across the surface of the tropical Atlantic Ocean from the Gulf of Mexico all the way to the coast of West Africa. A report in the journal Science claims that computer simulations show that this belt of brown macroalgae sargassum can weigh as much as 20 million tons in a good season. The massive bloom's shape is determined by ocean currents. Satellite imagery shows that major blooms have occurred every year between 2011 and 2018, except for 2013, when no bloom developed at all. Scientists say that's because seed populations of sargassum, measured during the winter of 2012, were unusually low. Before 2011, most of the free-floating sargassum in the ocean was primarily found in patches around the Gulf of Mexico and the Sargasso Sea, so named because of its popular algal resident. In patchy doses in open ocean, sargassum contributes to ocean health by providing habitats for turtles, crabs, fish and birds, and like other plants, producing oxygen through photosynthesis. But too much of the seaweed can crowd out marine species, especially near the coast. Scientists say sargassum populations began to explode in response to increased nutrients due to changes in ocean currents brought about by climate change. So, what do you think? Was Michael Jackson better looking before or after plastic surgery? Well, US researchers say people tend to find men more attractive, more likable, and more trustworthy after they've had cosmetic surgery done on their faces. The findings, reported in the Journal of the American Medical Association, also found that people felt men who had plastic facial surgery also had improved social skills. Researchers surveyed 145 participants, asking them to rate photos from 24 men both before and after going under the knife. The authors say this kind of facial touch-up appears to not only boost one's physical attractiveness, but a variety of personality traits as well. As for me, I think Jacko should have stopped at Thriller. If you're on the market for a new cell phone, now might be a good time to buy, with the launch of the 5G network and a gaggle of new cell phones full of gadgets. With more, we're joined by Alex Horosh from whistleout.com.au.
Nokia just launched 2 new budget smartphones in Australia, the Nokia 4.2 and the Nokia 3.2. These come in at $299 and $249 respectively. So they're like some of the cheaper devices around in the market and also in the Nokia family. So these are pretty basic smartphones, but they do have a few unique features. There's facial recognition in both the phones. It's not quite as secure as what you get in, say, like an iPhone 10. Because like it's just, I guess, 2D facial recognition rather than 3D technology, which requires more cameras, infrared sensors, and the like. But it is still facial recognition in a cheap phone, which is pretty cool. There's a notification light around the power button, which is pretty nifty. So if you've got your phone down, like face down, and you get a notification, the light around the power button will light up, so you can tell that you've got a new message or an unread email just by looking at the button, which is, I really like. It's a really cute idea. And these phones do run Android One, which is, I guess, kind of like a version of Android that Google helps maintain directly. So when a phone runs Android One, it's guaranteed to have at least 2 major operating system upgrades. So these run Android Pie, so they'll go through get Android Q later this year, and then Android R. But they also get 3 years of security updates, which is kind of unheard of when it comes to cheaper phones.
The basics, how big's the screen, how many pixels has it got, sort of RAM do the phones have, how long's their battery last?
The Nokia 4.2, it's got a 5.7-inch display, like mid-tier Snapdragon processor, 3 gigabytes of RAM, 32 gigabytes of storage, and a 12-megapixel rear-facing camera with a second 2-megapixel lens for depth, and it's got a 3,000 milliamp hour battery, which should comfortably be a day. The Nokia 3.2 is a little bit bigger. It's got a 6.2-inch display, again, like a mid-tier Snapdragon processor, 2 gigabytes of RAM, 16 gigabytes of storage, a 10-megapixel camera, and a 4,000 milliamp hour battery, which Nokia says will last up to 2 days.
That's Alex Horosh from whistleout.com.au. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.